I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, December 12th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Niño, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see a gale developing in the northern Gulf, producing 29-foot seas aimed well at California, with maybe a little bit of sideband energy at the Hawaiian Islands, and also another weaker system off the Kuril Islands, generating 28-foot seas, but not really of any interest at the moment. At least for now, there is some swell generation potential occurring. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, that is a dip in the jet to the south, just like here. That helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, when it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So we have a good trough up here in the northern Gulf being fed by 190 knot winds. That's certainly helping getting a circulation going. And as we know from looking at the significant wave height charts, there's seas already at 29 feet being generated in this area. But let's go from the beginning. Over Japan, the jet is consolidated, one even flow, pushing off with winds about 170 knots. You can't really tell, but it's sort of splitting. Some of the energy pushing south here, but most energy ridging way to the north. This sort of northward bowing jet helps create high pressure right here. And then when it dips to the south, you have low pressure here. So low pressure here, high pressure here, radiating clockwise and counterclockwise. Between the two, there's a gradient. That is a tightening of the isobars, and that in turn generates winds, and of course wind generates surf. So that's what's going on at the moment. Put this into motion. As we get into Monday, the trough, the apex of the jet, right down here, starts falling further south off of California, bringing the fetch closer to northern and central California, and then the apex of the trough right off the San Francisco area on Tuesday morning, and then pushing onshore. And with that, no more fetch over water, no more swell production, but a copious amount of cold air and precipitation pouring down over the Sierra, expected to generate much snow. And then even as we get into Wednesday, a secondary trough develops that might help generate wind swell, but mainly more precipitation. And then maybe even another trough right along here as we get into late Thursday and Friday. That might help generate something as well. But then you get into Saturday, you can just see a broad ridge, the jet heavily split here, high pressure in between, and just a diffuse, ill-formed jet stream flow over the entire eastern half of the Pacific, pretty much just shutting things down. And that continues into Sunday. I mean, you almost get this sort of backdoor trough trying to organize here north of Hawaii. Maybe that'll generate a little bit something. I mean, good solid winds here off Japan, but they just hit a brick wall right around the dateline. When we get into the MJO discussion later, there's a reason for that. All the energy is focused now in the far west Pacific, and the east Pacific, as you can see here, is just forecast to be a complete mess. So let's take a look at surface level pressure and surface level winds. As expected, the broad gale in the northern Gulf generating 40-knot winds, pushing towards the California coast, generating seas, high pressure right behind it, not unexpected, 1036 millibars, another little low off the Kuril Islands. Put this into motion on Monday. The gale off of California starts fading with 30 to 35 knot winds. New gale starts pushing off Japan, building with up to 45 knot winds, pushing straight off the coast there. As we get into the evening, the gale continues to fade. And as we're into Tuesday, the gale all but gone off California. Maybe the new one starting to queue up in the northern Gulf of Alaska. And this system off the Kuril Islands lifting north, not pushing east at all, not even making it to the date line. And then as we get into the afternoon, pretty much more of the same. Wednesday, new gale off of the Pacific Northwest, generating 35-knot winds, maybe a little bit more swell, but mainly more of a weather producer. The gale off the Kuril Islands, all but gone now. You get into Thursday, pretty weak pattern setting up. A gale trying to organize, but notice they come off Japan. They just all go due north, driven by high pressure, the split jet stream flow, the jet pushing like this and then due north, and the storms just follow it right up into the Bering Sea. Literally nothing as we get into Friday. Little gale trying on Saturday in the Gulf. Another broad system perhaps pushing off Japan on Saturday. We'll see how much traction it really gets. And it, too, heading due north to the Bering Sea. And then we get into that the cutoff low type thing north of Hawaii as we get into Sunday. But that's pretty much it. So right now is probably the peak of storm or swell production, at least for the moment. Now, we're looking at significant wave heights. We're going to go back in time to Friday, just a day or so. The gale that started developing the northern Gulf on Friday afternoon with 26.1 foot seas. We'll say 25-foot seas right in this area. And then starting to get a little bit more traction as we get into Saturday with 28-foot seas, 28.2 feet, the highest seas over this entire domain. And then in the evening, up to 30-foot seas, and then this morning, 29-foot seas. And now let's go look at the forecast. Here we go. The gale pretty much peaked out, or even a little bit past its peak, with 29-foot seas. So we get into Monday morning, seas down to, what is that, about 20, 22, 24, 25, maybe 26-foot seas off the North California coast, radiating well into California, even Southern California to see some energy from this one. New system starts building off Japan as we get into Monday night with 30-foot seas. And then, so we get into Tuesday, the gale fades pretty well off of Point Conception with 21-foot seas. The other gale off of Japan, again with 26-foot seas, but you see it, the fetch lifting north more than pushing east. 27-foot seas as we get into Tuesday night. And into Wednesday, it's all but gone. New system starts developing off of Oregon with 22, 23-foot seas. Swell certainly going to radiate down into North and Central California. Quality of that swell certainly debatable given the close proximity to the coast and probably a lot of local winds expected at the same time. We get into Friday, things quiet down considerably. New gale tries to develop off of North Japan as we get into Saturday with, this is new. This is an update here with 38-foot seas pushing nearly 40 feet as we get into Sunday, but again, lifting well off to the north, pretty much out of the picture by the time we get into late Sunday evening, but maybe some swell radiating across the date line, small swell into California, probably more so for Hawaii. And there we are at 180 hours out. We know the jet stream is a split mess over here, all the energy focused in the West Pacific. Next up, we take a look at local winds. Clearly, the gale in the Gulf filling the bulk of the picture, 40-knot winds aimed well at California. Where's Hawaii? Down here. Sideband energy for sure will radiate down into the Hawaiian Islands. But you can see southwest winds in control, we'll say from Monterey Bay northward. That was as of Sunday at 12Z. And as of right about now, that front still holding solid along Monterey Bay, 20-knot south winds. As we get into Monday, the front seeps south almost to Point Conception, a well-entrenched southwest flow along the entire California coast north of Point Conception, and then starting to sag south into Santa Barbara County or so as we get into Monday night. Again, southwest winds in control, not really good surf conditions. Then the front actually makes it down well even to San Diego County with south winds there, 20 knots as we get into Tuesday morning. More northerly flows starting to set up over North California. New gale developing up in the north. Tuesday night, northwest winds supposedly 20 knots, 25 knots pushing near shore into Southern California, and even a pretty healthy northerly flow from, we'll say, Point Reyes southward, something like that. And then as we get into Wednesday, a bit of a break, at least for Central California. But the next front starts moving into Cape Mendocino with 20, 25 knot southwest winds, pushing down to San Francisco in the evening. And Thursday, that system fades out, pretty much peters out, and then we get into, where are we? Friday, just a weaker northerly flow, and then things settle down for sure as we get into Saturday and Sunday. Relative to Hawaii, we kind of just bypassed it all. Most of the winds east of the islands here, 20, 25 knots, good for wind swell, but no immediate real weather impact for the Hawaiian Islands. Precipitation relative to California. Yes, there is precipitation, and a pretty good amount of it starting to work its way south. The line, somewhere around Monterey Bay, something like that. It's been snowing up in the Sierra and the Tahoe area since before sunrise. Very light, but getting steadily heavier as we get through the day. And you can pretty much see that here on the charts. As we get into Monday, heavier snowfall along the Sierra, rain the whole way down to almost Point Conception. By Monday evening, very heavy snow in the Sierra. You do not want to be traveling. You do not want to be trying to get over I-80. All the other passes, I assume they are closed already. Rain working its way down into Southern California, maybe down to San Diego overnight. And as we get into Tuesday morning, very heavy snow in the Sierra from Tahoe the whole way down to Mammoth, mainly focused here on the west side of the Sierra, and rain the whole way down to San Diego, and then sort of blowing through as you get through Tuesday with clearing in Northern California, and then by Wednesday morning clear into Southern California. But the next system lines up, much less precipitation, but still pretty good precipitation by mid-morning Wednesday from San Francisco northward, and then San Francisco down into Tahoe with snow again forming there, pushing its way down the Sierra as we get into Thursday morning, whole way down to Mammoth, and then pretty much lightening up and fading overnight. And then we get into Friday, much clearer regime. Saturday, clear, maybe some more snow on Sunday, working its way down into the Sierra, but not a heavy snow producer, and more rain. California will take every drop we can get. As much snow as possible accumulated in the mountains we are hoping for. It doesn't even matter in terms of skiing. This is all about getting water in reservoirs, building up the snowpack, doing anything. We've been through a long run of the inactive phase of the MJO. It's been beautiful weather, no wind, but no precipitation either. A quick look at snow for the Sierra right here. You can just see it where we're at 5 p.m. on Sunday. Actually, it should be 4 p.m. I got to update that. But you can see the snow build up here in the Sierra as we get into Monday night. There's the heavy line of snow. What's that? 21.17 inches in a 6-hour window. That's a lot of accumulation, almost 2 feet in 6 hours as it pushes its way down the Sierra and then fading out as we get into late Tuesday into Wednesday. But then the next little system moves in Wednesday night, pushing its way down the Sierra on Wednesday into Thursday. And then, let's see, one more we think. Here it comes. There we go. As we get into Monday. So this would be a week. This is a 10-day model. This one looking, again, like a pretty moderate to heavy snow producer as we get into Tuesday, over a week out, and then things dry out. So some definite potential. Let's go look at accumulations. So for Olympic Valley, you can see snow off the chart. Most of the accumulation right in here in between, we'll say the 12th and the 14th, that next little bit on the 15th into the 16th, and then yet another amount of accumulation out through about the 20th. We'll click on this and we can actually get the actual amounts. Supposedly 163 inches over a 10-day period, but probably about 107 inches. So what's that, about 9 feet, something like that for the main event here through the next couple of days. And then we'll see about this next event, whether this is for real or not, but that suggests another maybe 40 or 50 inches on top of that. It would be great if it were true. Mammoth being further south, and these storms all traveling due north to south, less accumulation, somewhere in about the, we'll say 80 inches, but that's still quite respectable. And given their higher elevation, it will probably be a very dry, light, powdery snow. So not a bad way to start the season off. Let's go back to Squaw. Here we go. We're checking out snow levels. This is the base of squat, about 6,200 feet. The summit, right about 9,000 feet. For the next several days, snow level, well, as of this afternoon, we're saying, I mean, it's snowing to the base. This says maybe slush at the base, and maybe that's true at the, at the heating of the day, but we're past that already. Theoretically, snow level going down to 1,000 feet on the afternoon of the 14th, and then still well below the base the whole way till the evening of December 16th, then going up to the top, but then falling back down again. So really good snow levels, and it looks like a reasonable amount of precipitation on its way in the Bay Area. Rainfall accumulations, I think we're hearing in the 3.25 inches, depending on where you are, but just sort of in general, we'll say 2.5 to 3.5 inches, something like that, of liquid precipitation. Of course, when you get the elevation, that squeezes more precipitation out. Strong moving winds with moisture-laden winds being forced high to elevation wrings out every drop of precipitation. So you get an amplifier effect, which results in these kind of snow totals. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, El Niño or La Niña. As usual, we'll start off looking for signs of the active phase of the MJO, the Madden-Julian Oscillation, that periodic weather oscillation that travels around the planet. The active phase on one side of the planet, the inactive phase on the other. Wherever the active phase is, and especially when it's over the Pacific, what it does is it's effectively a low-pressure system. It feeds energy to the jet stream, which it's doing right now. It also helps create cloudiness and potentially shifts trade winds over the West Pacific, reduces them, and that allows warm water in the west to start pushing to the east. All right, so right now, this is stale data. We notice this. It hasn't updated since December 9th, but still, we're looking at, here's the equator. The arrows is what we're looking at. Wind speeds from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. The arrows, strong easterly trades over the East Pacific, strong over the Central Pacific, pretty strong over the West Pacific. That's New Guinea there. There's the equator, of course. East Pacific there, West Pacific there. But it's not the actual wind speeds, it's the anomalies, differences from normal for this time of year. And the trades in the East Pacific, a little bit stronger than normal. You see the arrows out of the east. Over the Central Pacific, a little bit stronger still than normal. And then over the Kelvin wave generation area, this is the important area that when the active phase moves over here, it really does its best to impart energy into the jet stream. About normal there, a little bit stronger than normal. So this sort of looks like the inactive phase of the MJO, but we know different, and we'll show you why in a second. So here's the forecast for the next 7 days. This is the whole planet on one chart. The date line runs right up the middle. The far East Pacific, like Ecuador, this is on the equator. Right there, you can almost see a seam in the picture right there. The far West Pacific, 135 east, so like right there. The reds are westerly anomalies. Consider that the active phase of the MJO. The blues are easterly anomalies, the inactive phase of the MJO. You can see the area we're interested in is the far West Pacific, from about here to about the date line right here. So you can go right up the picture, and you can see blues, easterly anomalies until about December 4th. Then all of a sudden, westerly anomalies started moving into the West Pacific, the active phase of the MJO building. Today, pretty solid, strong westerly winds almost making it to the date line, but the active phase of the MJO is supposed to give up some ground here in the next couple of days, but still holding reasonably, filling 50-60% of the Kelvin wave generation area with easterly anomalies east of there, but not giving up the ghost entirely. Not a bad situation. Looking further out, 2 weeks out, this is outgoing long-wave radiation. Fancy words for cloud cover or precipitation potential. All right, 4 different panels, 5 days each panel. South America, Central America, Hawaii, Equator, EQ, right there, right down the middle. New Guinea, Australia, dateline 180 west right there. So the area we're interested in is right here, the Kelvin wave generation area. And we see blues Active phase of the MJO. Lots of cloud cover. Remember, we said the active phase is like a low pressure system. Low pressure generates clouds and precipitation. So it's right where we want it, over the Kelvin wave generation area. Continuing 5 days from now, 10 days from now, still partially over the dateline 15 days from now, according to the statistic model. The dynamic model right here, painting pretty much the same picture, maybe the active phase not moving east quite as quick, which is a good thing. All this suggests good swell generation potential, at least where the active phase is. Now, the interesting thing is typically the active phase feeds energy to the jet stream over the whole Pacific. But if you remember from the jet stream charts, the jet stream makes it to about the dateline, 180, right about there, and makes it no further, and then it splits with half energy going north, half energy going south. So the jet stream, as of right now, looks like it's being fed by the active phase of the MJO, and it's supposed to, but the active phase has to make it with strength south of the East Pacific before the jet stream will really start raging there, and we're not sure whether that's going to happen or not. In either model scenario, at least for the next 2 weeks, the split point to the jet stream looks to be no further to the east than effectively Hawaii. All right, next up, phase diagram charts. These charts are a deeper dive using the same two models, statistic model here, dynamic model here, but they show you exactly where the core of the active phase is in relation to everything else and how strong it is. So the MJO moves from west to east, from the Indian Ocean over the maritime continents like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, then back to the Indian Ocean. Where the heavy dot is where the active phase is. It's in the West Pacific. That's good news. And even better, the further away the dot is from the circle, the stronger it is. So a moderately strong active phase over the West Pacific. This is the first time we've seen this since it's been quite a while, a year or two since the La Niña got going. Now these are the three different forecast tracks. Two of them have it moving to, we'll say, the Atlantic Ocean and weakening. But the dynamic model over here suggests, well, the active phase sort of backtracking and then meandering along, only making it to the East Pacific 2 weeks from now, and still, we'll say, moderately strong. Not too bad a scenario. Next up, we look at the upper level model, potential for precipitation. Greens are favorable for precipitation, the active phase. Yellow is not favorable for precipitation, the inactive phase. 8 different panels. This goes out 40 days. South America there, Central America, little tip of Hawaii, New Guinea there. Where's the equator? Right there. Okay, Kelvin wave generation area roughly here. So precipitation, active phase in the Kelvin wave generation today, continuing its way across the Pacific into Central America, first week of January, we'll say. Inactive phase follows behind that, getting pretty solid by about Christmas, making its way across the Pacific to the end of the model run, January 21st, but then another active phase showing up. The good news about this chart is it's actually showing a semi-normal active, inactive, active phase pattern. Okay, we haven't even had that for months, and we got some other charts you can see, but the normal rhythm of the MJO has been completely out of whack, totally favoring the inactive phase. This sort of suggests, and that's typically what drives La Niña, but if this normal pattern starts setting up, that's suggesting that perhaps La Niña is coming to an end. We want that. All right, so this is, again, going out even further. Goes out 1 month here. You can see, okay, so where are we? There's the date line running right up the middle, right there. Okay, you have the solid contours of the active phase. The dotted contours are the inactive phase. And you see active phase with the oranges and reds, those are westerly anomalies. That's what feeds the jet stream. Then you have the inactive phase. This happened where? Late October through about a week ago, through the end of November, okay, with easterly anomalies, pretty much stealing energy from the jet stream. And now you have a building active phase today, making its way across the, well, there's the date line right there, the far West Pacific, 135 east, so right there. So our area that we're interested in is right along in here. Active phase with 2 contours pushing through the Kelvin wave generation area through about the 1st of January, building some pretty decent westerly anomalies the whole way. Then here comes our inactive phase of the MJO behind that. And then finally, the 3-month CFS model, all right? Now, so this is the same chart, but the past performance is down here. The forecast is up here. Yellows are westerly anomalies. Blues are easterly anomalies. The date line right there runs right up the middle of the chart, okay? Right here, this is October. Westerly anomalies trying to push across the Kelvin wave generation area. Today's active phase, a little bit stronger, a little bit more yellows as compared to that, and almost continually linking, making its way across the Pacific. That's a good thing. And then another one forecast even stronger. And so you go from pretty much all blues to a little bit of yellow and blues, a little bit stronger yellow, blue, a little bit stronger yellow, again suggesting what appears to be, just eyeballing it here, the active phase of the MJO slowly building strength over time. Again, this is just a forecast. It is not reality. So let's sort of just dig in a little deeper. So back in October, the solid contour here, that's our active phase of the MJO, followed by our most recent, the dotted contour, inactive phase of the MJO, which doesn't support storm formation. Now we have our active phase of the MJO that we're currently in right now, supposedly hanging around till about New Year's. Then a pretty strong inactive behind that, and then a much stronger active phase starting, roughly about mid-January and going through about the end of February, something like that. Now, also consider, so this was fall, our first active phase. We're right around Christmas time here, our second active phase. One more, and then it's over, and you're into spring after that. So we've got whatever we're in right now as a window of opportunity to the end of December, and then we've got another opportunity somewhere between late January and late February. And after that, I suspect you're going to see raging north winds along the California coast, strong trades pushing over Hawaii, and we're back into that springtime, just wind time mess of a hole, and then it's over for the season. That said, we had rated or estimated that on a 1 to 10 scale, 1 being the worst, 10 being the best, that this year would be a 3 for significant storm production in the North Pacific Ocean. Yesterday, we almost downgraded it to about a 1.5. I'm going to hold our breath for a little bit and maybe, not go that radical, but sort of looking at this, looking at the timing, looking at what the models are saying, looking how there doesn't appear to be any, other than this one sort of gale, local gale thing that's blowing into California, there's going to be nothing after this in terms of making like 15-foot surf or larger. And that's what you need to get winter swell down into Southern California from a relatively steep north angle. I mean, the jet's just way to the north. I mean, this is all typical La Niña sort of stuff, but a strong La Niña at that and a bad winter in terms of storm production. All right, so let's do one more layer on top of here. This dotted line is a bias towards high pressure, okay? The La Niña bias, if you will. The solid contour is the low pressure bias on the planet. It's over here at about 120 east. That's like the Indian Ocean, Bali, maritime continent. While high pressure locked over the date line, that explains why this year has just been such a lousy storm-producing year, because La Niña effectively sets up high pressure over the Pacific Ocean. During El Niño, this is reversed. The high-pressure bias is over Australia. The low-pressure bias is over the date line. The Pacific goes wild, and then Australia goes into drought. So that will come at some point, just not right now. All right, so digging deeper now, down into the Pacific Ocean. Now we're into the El Niño, La Niña part, deep into the discussion. East Pacific here, West Pacific here. This is the anchor lines on the TAA buoys. The X's are sensors on the anchor lines. Use a model to connect or build data in between where the data is not present, and you get a profile of where the hot water is and where it isn't. Warm water in the West Pacific here. You can see much less warm water, a very shallow layer of surface warm water in the East Pacific. But it's not the actual temperatures that matter, it's the anomalies, differences from normal for this time of year. This chart is almost unchanged from last week. Warm water in the west, 2 degrees centigrade above normal, holding brick walled off here, right where the jet stream is splitting. That's where the, near the date line, that's where the warm water makes it there and not 1 inch further. Now, the good news is colder than normal temperatures here, 2 degrees below normal. It was actually colder last week, and it's getting slowly weaker and moving off to the east. There has been a massive cool pool here locking things down, driven by stronger than normal trades on the equator, creating much upwelling. We think that is slowly starting to give way now, not to a normal regime, but just not as cold as it was. In fact, let's look at another chart. Same data, same sort of picture, the brick wall right here, warm water in the west, building even stronger warm, but just blocked off at about 170 west, right close to the date line. Colder water, but much less pronounced, just turning more and more just sort of a generic cooling pattern rather than some death circle of dark cold water here, which it was for months prior to that, suggesting perhaps the demise of La Niña. And even more so here, this is sea level anomalies, Jason 3 or whichever satellites they use, just trying to, so this is measuring the height of the ocean, the sphere of the ocean. Okay, strip out the wind waves, strip out the waves, strip out the tide. Is the ocean higher or lower than normal? Let's get oriented here. Chile, Peru, this line here is the equator. There's Central America, Baja, Hawaii right there. Dateline right there, New Guinea right there. You can see below normal and just a triangle here from Chile out to the intersection of the dateline and the equator up to the southern tip of Baja. Lower than normal heights on the sphere of the ocean. But the good news is it was down at 25 centimeters below normal in this area a month ago. And then 20. And now these two little pockets of 15, and they even seem to be, losing coverage. 10 centimeters, though, holding pretty solid almost from the date line into Peru. We want to see that start to fade, but it suggests a well-entrenched, yes, and lower than normal heights here suggest cold water at depth. Cold water contracts, so it creates a divot on the ocean surface. Also, strong east winds here scoop water out from here, build it all up here, and then hold it like a brick wall as the east winds continue to blow, all driven by La Niña. But as this cool water starts warming and that cool pool down at subsurface all bubbles up to the surface, the water will start warming, and then the trades will start backing off, and then all this warm water will start sloshing to the east, and that is how you get El Nino. And once you get El Nino, then much energy gets imparted, then the high pressure bias breaks down, the low pressure bias moves into the Pacific, and then all of a sudden that sets you up for the low pressure bias building in the Pacific, and then you get into winter months, you get El Nino, and of course everyone knows that's good for rainfall in California and good for storm production over the North Pacific in winter months. This chart sort of tells it all right? West Pacific here, East Pacific here. This is upper ocean heat anomalies, not at the surface, but close to the surface. Last year, January, colder than normal waters in the East Pacific, warm water all balled up here in the west. Kelvin wave. There's a little bit of a break in March. Active phase of the MJO kind of woke up. We got one Kelvin wave, warm water sloshing across. A second, a third. Then we got in July, and again the cool pool started building. Very strong, much stronger in October of this year than it ever was last year, and much broader in coverage. But you see now that has rapidly faded, and the last little bits of it trying to work its way to the surface. Still this large lingering sort of damage left over from this thing as it's all gurgling out. It's got to work its way out. And you also notice warm water starting to build pretty solidly here over in the West Pacific. In fact, last year It was, let's see, 1, 2, 3 in December. And where are we at? 1, 2, 3, almost 4. So about like where we were last year. We'll see what happens as we get into March and April. Will the MJO really wake up, produce some Kelvin waves, and kick La Niña out for real? I can't imagine we're going to go into another fakey where we have this third year of La Niña. In fact, I don't ever recall there being such a thing as a 3-year La Niña. So, but don't want to say that absolutely won't happen. All right, sea surface temperature anomalies, differences from normal for this time of year. Peru, South America here, Peru, Chile, the Galapagos right there. Central America, Baja, Hawaii, the equator right there. Again, a lot of very cold water trying to gurgle to the surface here right by the Galapagos. The last of that cool pool working its way to the surface. These temperatures right off of Chile appear, just eyeballing it, appear to have warmed a little bit the past week. Not a lot, but just a little bit. And you get the sense there's some warming going, or warmer, almost normal temperatures in pockets where they weren't there before a week or 2 or 3 weeks ago. Not saying that it's warming significantly, but just, any little shade of hope. In fact, here's the trend, sea surface temperature trend the past 7 days. Warming, it's really on the equator we're interested, though we sort of kind of like to snoop around right here off of Peru and Chile. Maybe some light warming there, but light warming off of Ecuador. Couple of pockets of cooling still, but also interspersed pockets of warming. Kind of looks like a balance. We're not getting any colder on the balance. We're not getting any warmer on the balance. We're at a homeostasis. We're just neutral, not going anywhere, at least for the moment. And then here's the backed off view. I mean, clear, it's still obvious. Colder than normal temperatures are in control of the equatorial Pacific from Ecuador the whole way out to the date line, which is there, and then even beyond that, a clear La Niña signal. If this were El Niño, instead of this water being cooler than normal, it'd be warmer than normal. We're not there at all. All the warm water balled up somewhere over here or in the Atlantic, equatorial Atlantic, but not in the Pacific. A redistribution of heat is going on, at least for the time being. Sea surface temperature trend in the Niño 3.4 region. I know there's a really small little graph, but you get the idea. We warmed in the summer, crashed in November. Temperatures may be trying to come up a little bit. This is the official El Niño monitoring region. In the Niño 1.2 region, the region right off of Ecuador, temperatures pretty much holding where they are. So let's go look at some harder data. Again, temperatures in the Niño 1.2 region, the area right there along Ecuador and Peru, pretty much stable at minus 1.693 thousandths of a degree. So, and holding roughly there since about mid-November. So for the past month, not getting any colder there. But you can see we were definitely warmer. Half a degree below normal is the official El Niño threshold. It has to be for about 5 consecutive months. So clearly in La Niña territory since fall began. But it's the official El Niño monitoring region, the 3.4 area, half a degree below normal. Well, La Niña for sure since early October. But where are we? We're right here. Temperatures don't seem to, in fact, they're even warmer than they were back in October, not going anywhere. This is kind of interesting. It sort of seems like we've plateaued out. When we get into looking at what the forecast temperatures will be, they suggest we're supposed to keep going down, but I'm beginning to wonder if that's really the case. Just the underpinnings of everything we're looking at suggests it probably isn't going to get any colder than what it is right now. At least, I'm hoping not. So what does the atmosphere think is going on? Okay, if you have cold water at the ocean surface on the equator, then typically you get high pressure, stable air above that. All right. So what is the pressure differential going on? If we have a high pressure bias over the Pacific, lots of cold water, then you'd think you'd have lots of high pressure. All right. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific. Darwin is roughly the Indian Ocean. If pressure is lower in Tahiti, like a low pressure bias, then the index is negative. Today's value, it's positive, 12.40. And just eyeballing it down here, it's, well, we've got two negative readings in the past month and some pretty high positive readings, 30.98. But so still definitely indicative of a La Nina pattern. The 30-day, but this is noisy. Let's go look at the 30-day average, sort of smooths things out. Today's value positive, 11.48, but we were 12.67. Well, we're also, know this, we're in the active phase of the MJO, so that will start dipping these numbers down a little bit. But where were we? We were down at 6.1, 5.88, something like that. So the index went up as the inactive phase in, in November took over. Now we're moving back to the active phase, the index dipping some. But you don't see any nary a negative reading here. So how active is this active phase? Anyway, and then the El Nino La Nina indicator, the 90-day average. Today, 9.94, actually coming down a little bit from 10.22, but we've been in the 9 range for a month now. So this index here, I think, went up to plus 19 at the peak of La Nina, like in early January last year. We're at 11. I don't know if we're going to get to 19. This one went to plus 15. I don't think we're going to get there either. At least it doesn't look like it at the moment, especially seeing how there's a real, or at least a semi-real active phase of the MJO in control right now. It's pretty hard for these numbers to go up when that's happening. So kind of some good news here. In fact, here's the graph, the trend, the 30-day moving SOI, all right? Back in 2019, sort of like a weak El Nino. And then in 2020, again, the downward spikes are the active phase of the MJO. The upward spikes, the inactive phase of the MJO. When the inactive phase is dominant, it pushes the index positive. Okay, this summer, we had a good, strong active phase. It sort of pushed the index down, but then in July, that was over. So here we are, early December. We're at about plus 11 or plus 12. But last December, where were we? We were on a tear heading upward. This year, we're just moving into the active phase, the index going down. So it seems pretty hard to think that we're going to get as high a value as we got last winter during this winter. That's not to say it won't happen, but with cold water at depth dissipating and just the general feel like La Nina's done its thing, maybe we won't go as high as last year. I don't know that that's going to rescue us from this winter, but we'll get into that in a minute. Let's keep going. One last chart. Sea surface temperature anomaly forecast for the Niño 3.4 region, the official El Nino monitoring region, the area, the ocean temperature on the equator south of California to a point out about by the dateline. So here we are, somewhere around mid-December. Says the temperature is about 1 degree below normal, which is about like probably what it is. And temperatures falling to minus 1.4 degrees in mid-January. And then slowly but steadily working their way back to normal by July. Now that's kind of the noisy chart. The PDF corrected, though, now almost exactly in line, saying, what is that, minus 1.35, 1.4 degrees. So for, a week or something like that. So temperatures and then temperatures rebounding. So these, though, are suggesting that the peak of La Nina still hasn't been reached. We've still got another month to go. Everything else sort of suggests that's probably maybe true, but maybe not. I'm thinking this might be a little bit of an overstatement. This model does tend to sort of overstate the situation sometimes. All right, for right now, there's a gale in the northern Gulf, generating for sure some seas and swell on the way, but very raw, probably blown out mess. Southern California, probably the best call of anywhere if the swell can actually get in there. But lots of rain, snow forecast for the mountains and even the coastal areas of California. That's all good news. And a series of smaller systems right behind that, hopefully generating yet more snow and maybe a little bit of raw swell. After that, kind of a mixed bag. The jets split on the dateline heavily, and not a whole lot of hope for real swell production. Certainly nothing significant. The thought that maybe we will downgrade the winter outlook even more is very much a possibility in the next week or two. Looking longer term, though, the peak of La Nina, maybe we've already reached it and we're past it. The models say not. Everything else sort of suggests it is. We'll just have to see on that. Either way, even if the peak is over, there's a lot of atmospheric damage that's been done in that the jet stream is in a pattern. It's in a rut. That's not going to just turn on a dime in a month or two. It's probably going to take till May, June, or something like that for it to recover and to start to move into a more normal pattern. So pretty much this winter, La Nina pattern for sure the whole way through. Take anything you can get swell-wise, snow-wise, rain-wise, and make the most of it. Just get what you can. We talked about this earlier in the year. It's La Nina. Didn't think it would be quite this bad, but it certainly is. Maybe the worst winter surf season ever on record. But the good news is we're through the worst of it, we think, and it's only going to be getting better from here. Maybe not for this winter, but hopefully by the summer. So that's it for this week. If you enjoyed the video, give us a thumbs up. There you go. If you haven't subscribed, please subscribe. Questions, comments, welcome. We try to answer them immediately, and a lot of people just write in and say hi, thanks, and we really appreciate it. I try to write back to everyone and let them know that I do personally really appreciate y'all watching and giving your feedback, providing any constructive criticism. It's welcome. If nothing else, I'll see y'all at the beach. We'll go surfing together and have a good time. All right, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching. Bye.